Hello world, I am going to show you how to connect a tachometer and make it work with a car that has a 3-cylinder engine. Now those of you who don't know, like aftermarket tachometers like Autometer and DeFi or whatever it's called, they only come with options for 4-cylinder, 6-cylinder and 8-cylinder engines, just the nature of the signals they take. And I'm going to show you how I've made it compatible with a 3-cylinder engine. Now this is my car, it's a 2016 Renault Twingo 3 on my friend's lovely drive, because I'm not rich enough to have a drive like that, but there you go. This is the engine of my car, and you can see these coil plugs. Now it'll be different on every car, but on the Renault Twingo, I believe the top wire out of these three is the signal wire, because I've found someone on Facebook has tried to do the same thing. I don't know how successful they were, I just found this image. And you can see here, they've spliced the wire on the leftmost, or the top one, depending on how you're looking at it. So I'm assuming that's a signal. I haven't actually done this. I haven't connected it to my car yet, because my car has warranty, and if you mess with any electrical stuff in your car, you lose your warranty. So do at your own risk, I suppose. Now, this is the circuit I've come up with. Essentially, my idea is, and I am pretty certain it's going to work. I know it's blue, I don't know, it's very difficult to tell what colour the wire is. I think that's blue, but there you go. You splice the wire into an Arduino, which multiplies the frequency, because this is frequency of the signal of 1 cylinder. To make it compatible with the tachometer set on 4-cylinder, on the 4-cylinder mode, because you can change the modes, it goes into an Arduino which multiplies the frequency by 4, and then the Arduino sends that to the tachometer. Obviously it will go from 12 volts, because that's what cars use, to 5 volts, which is what Arduinos use, and then back to 12 volts. So you need to transform this signal down to 5 volts before it goes into the Arduino, and then you need to transform it back up to 12 volts to the tachometer, because these run on 12 volts as well, because they're just designed for you to go straight into them, but obviously we can't do that. This is the circuit I've come up with. So this pin here, if I set it to you, then this pin here, this terminal, 12 volts is on this, then it's ground, then it's another 12 volts for the tachometer. So this is 12 volts in from the car, ground to the car, then it's 12 volts for the tachometer, ground for the tachometer, then your signal out for the tachometer, and then your signal in from the ignition coil. So I'll show you the circuit. So here you can see the 12 volt source in. These Arduinos run off 5 volts, so we've got it going into a 12 volt, no sorry, not a 12 volt, a 5.1 volt Zener diode. Thank you, my school, because I didn't have any of these, so I managed to get some from my school. They went to a good cause, I suppose. I didn't steal them for no reason. This powers the Arduino, so this is V in. And then for your signal, this is the signal from the ignition coil, also gets transformed down to 5 volts, so this Arduino can read it, because you don't want to overload the Arduino. The Arduino does its processing, so you basically have a square wave coming in. This is what the car will send. because you know everything's digital nowadays. And then the Arduino does its processing, then it will output it to this Darlington NPN transistor, which transforms it back up to 12 volts and then out for your tachometer, so signal out for your tachometer. So it's a fairly simple circuit, I suppose. And here's the code. I will link it in the description somehow, probably a mega link. I didn't write this code, it's written by Andrew Q. You can see all of its credits here. Now, oh, this is lagging a bit. Oh dear. Give it a minute. Of course it does it while I'm recording. I might have to edit this bit out. Ooh. Here we go, we're back. Now, it's a very complicated code. It uses interrupts, so you get very good frequency response out of this, and it keeps the signal very clean. It's not noisy signal. There are many ways you can go about doing this, but I think using interrupts is probably the best way. And if you don't know what interrupts are, then I really wouldn't worry. It's very complicated. But essentially, I found this code. Thank you, Andrew. You're my G. Love you, baby. So then, now you have your signal. So to prove this works, I set up a test. Now, I'm fortunate enough to have an oscilloscope. So this is a square wave signal that I simulated. So I had two Arduinos. So I used one to simulate the ignition wire, because I haven't put it in my car, like I said. Now this is 396 Hertz. I tried to get 400 Hertz. The Arduino is not incredibly accurate, but the difference is basically negligible. So 400 Hertz would equate to, if my car was doing at its rev limiter 6,000 RPM, then that wire that we spliced from would be outputting a 400 Hertz wave. Now, here, so we have I've simulated a 400 Hertz wave because we want to simulate like the uppermost bound that we're using. Because there's no point simulating a kilohertz because my car's not going to output that. There's no point simulating 100 Hertz because that's not showing us if this is going to work at our limit. So as you can see, I know this is not, the bottom wave is not quite in line, but it doesn't show the channel 2 frequency here, but it did say 1.6 kilohertz, which is exactly what we wanted, because we wanted to multiply it by 4, and we multiplied it by 4. You can sort of see one period of the wave, so that from here to here is a period. Then we have 1, 2, 3, 4 in the middle of that, which is exactly what we want. So we know it works. And I know I've accidentally set my oscilloscope to French. I apologise for that, but it doesn't really matter. So I hope this has really helped anyone that wants to do this. If you don't know anything about Arduino, there are hundreds of tutorials on the internet. It's basically, you just plug it into your computer, you go up to tools, you click your board that you're using. I'm using a Nano. Then your port. These are ones from my sim racing setup, but it will say Nano. And then all you do is go, oh god, it's lagging again. You go verify and compile, and then after it's done that, you click upload, and there you go. That should work. And if you don't have the capabilities to make the circuit, which you do have to have quite a lot of electronics experience to make the circuit, because you have to make sure all the grounds are connected, and like all that stuff. if there's a demand for this, I will order some PCBs and I'll make some of these circuits and I'll sell them for, I don't know, say 60 quid, because they are quite a lot of effort to make. And the components, the Arduino Nanos aren't super cheap anymore. They used to be, but you know, everything's gone up in price. Thank you, governments of the world. So if there is a demand for them, I will sell them on my eBay page if you want. If you want me to sell them, just message me, or not message me, comment on down below and just say, oh, I really want one of these, this would really help me. So if enough of you do it, I'll start selling them. If not, you're just going to have to try and make someone some perf board. But there you go. If you enjoy this video, please like it, that'd be very nice. You know, I did quite a lot of research for this video, and yeah, if you have a Renault Twingo, that's pretty awesome. They're very nice cars. I'll see you soon.